Hello everyone, my name is Abolfazl Hajihassani. I'm an extension nematologist at the University of Georgia, Tifton campus. My research and extension program focuses on vegetable crops in particular. I'm going to give you an update on identification and management of plant parasitic nematode in vegetable production system. To start, I give you a quick update on identification of nematodes. In 2018, we actually started doing a survey for plant parasitic nematode. We collected 437 soil samples from vegetable field in the southern part of the state. We detected those nematodes, and based on this table, we identified 10 genera of plant parasitic nematode. Among those 10 genera, root knot nematode was the most prevalent groups. As you can see, 67% of the field were infested with root knot nematode, and the population density of root knot nematode ranged from 0 to over 14,000 per 100 cc of soil. As you might know, the damage threshold of plant root knot nematode is only one nematode per 100 cc of soil. That means that if you have a soil infested with root knot nematode and the number is greater than 1, you might need to use a management techniques to control the nematode. In this table, you can see some other group of plant parasitic nematode, and you might ask whether there can be an issue for vegetable production or not. I can tell you that the stubby root knot nematode, the lesion nematode, and the reniform nematode, they have been reported to cause damage to vegetable crops. However, their damage are really depend on the population density. For example, for the stubby root nematode, we saw the damage on onion, cabbage, broccoli, eggplant, and tomato. There are also two groups of nematode, as you can see here, ring nematode and spiral nematode. These two groups of nematode are really not a problem for vegetable production system. Although there might be a few crops that can be affected in case of high population density of these nematodes. However, we have not seen any damage of any vegetable crops by ring and spiral nematodes. As you might know, root knot nematode has different species. That's why we conducted a molecular test to see what species of root knot nematode are present in vegetable production system. Based on our data, the southern root knot nematode, Melodon incognita, was the most prevalent species identified. Following that, the peanut root knot nematode, Melodon arenaria, and the Javanese root knot nematode, Melodon javanica, had the greatest incidence. These three species are commonly present in vegetable production system, not only in Georgia, but also in other states as well. We also found two other new species for the state of Georgia, Melodon phalorensis and Melodon aplanaria. I'm going to talk a little bit about these two new species. Melodon phalorensis is known as a peach root knot nematode, and this is due to the fact that the nematode was first detected in Florida on resistant rootstock of peach. However, it is now found that this nematode can be an issue for some of the vegetable crops, including pepper, tomato, cucumber, squash, eggplant, and snap pea. One thing that I like to mention about this nematode is that Melodon phalorensis can overcome the resistance in tomato and pepper. As you might know, there are some varieties of tomato and pepper that are resistant to common species of root knot nematode. However, these new species can overcome those resistance. Other species that we found for the first time in Georgia is Melodon aplanaria. We only found this nematode in one location, which is a good news. However, this nematode can also be issue for tomato production. Although the nematode was initially found on peanut in Texas and Kansas, and later on on tomato rootstock in Florida, this nematode, similar to Melodegon floridensis, can also break the resistance in tomato. That's why it is very important to prevent the distribution of this nematode in the state. I'd like to mention that if you're growing any vegetable, any resistant vegetable crop, and you face with a high number of the nematode or galling on the roots, please let me know so that we can do an analysis to see whether they are a new species or not. In this slide, I'd like to also introduce you another species of root knot nematode, Melodegon enterolobi. This nematode actually was found for the first time in Florida infecting tomato. However, this nematode was more recently was found on sweet potato in 3 states of North Carolina, South Carolina, and Louisiana. Using a USDA grant, we started doing a survey for these nematode species in vegetable and also row crops, and we couldn't find this nematode until now. However, our survey will continue next year, and if you are interested to collaborate in our survey, please contact me or your extension agent so that we can collect sample from your field. One thing that I like to mention about these nematode species is that this species is very aggressive for production of most of the vegetable crops as well as row crops. For example, cotton and tobacco are also excellent hosts for this nematode. To prevent this nematode from introduction into the state, those growers who are interested in sweet potato production need to be careful to use certified nematode-free plant material, including sleep or tuber or seed. If you are bringing any material from other state, please be careful to use certified material. From now on, I'm going to give you some update on chemical control of root knot nematode in different vegetable crops. Here is a table of the fumigant product that are available for use in vegetable crops. Nothing has been changed. There is no new product to use. I just wanted to point out that the fumigant Paladin was stopped from production in 2019. We conducted a soil fumigation trial in 2019, and then we repeated in 2020 for the control of root knot nematode on pepper. In this trial, we had 5 treatment, 3 fumigant, 1 resistant varieties of pepper, and untreated shade. Here, as you can see, our fumigant were Talon 2, Dominus, and Picolor 60, and the resistant variety of pepper, Carolina Wonder, which is resistant to 3 common species of root knot nematode. All the fumigant were applied at the depth of 12 inch, and we actually collected the data on different factors. One of the factors for evaluation of nematode damage is to look at the gall rating. For that, we use a scale of 0 to 5. 0 means there is no gall on the roots, and 5 means that more than 70% of the roots were galled. As you can see, for example, in this picture, the gall index of 0 means that the roots are healthy, whereas the gall index of 5 means that the roots is full of galls. For the gall rating, as you can see in this graph, our trials show that the plot treated with Picolor 60 and Talon, and those plot grown with resistant variety, they had a lower gall rating compared to untreated check. If you look at the untreated check versus Dominus, there was no difference. Moving forward, here's the data for nematode count per 100 cc of soil. As you can see, we saw the same trend as for gall index. The plot treated with Picolor 60 and Telon, as well as the resistant variety, they had a lower number of the nematode per 100 cc of soil compared to untreated check. Again, there was no difference between the dominance and the untreated check. I'd like to mention that if you are dealing with root knot nematode in your field, Telon 2 can be a good nematicide for use. However, if you are dealing with some other soil-borne pathogen, for example, a fungal pathogen, you might consider using Picolor 60. Here's the data for fruit yield of pepper. For the pepper fruit, we actually categorize them in 3 groups: large fruit size, medium fruit, and small fruit size. If you look at the resistant variety in the previous 2 slides, you saw that the resistant variety did an excellent job in terms of the nematode control. However, if you look at the fruit yield, you can see that the large fruit and the medium fruit size, the yield is lower than the other treatments. Among the other treatment, the plot treated with the Picolor 60 had a greater yield compared to the others. Here's the table for non-fumigant nematicides for use in vegetable crops. Again, some of these products are available for a couple of years or many years. Like Whitehead is been available for decades. However, we had a couple of new products. Nothing new has been added to this table. There's another new nematicide that might come to the market next year or the following year called Salibro. This is the product from Corteva that has our preliminary test showed some good nematicide efficacy. In a trial that we did this past summer, we actually tested the efficacy of a couple of non-fumigant nematicide on tomato. However, we had 2 varieties of tomato. One variety was susceptible to root knot nematode, and the other varieties, Red Bounty, was resistant to root knot nematode. Our nematicide product were Magistine, which is a bionematicide, Whitehead, Velon Prime, and Nimitz. We applied Nimitz 1 week before planting. However, other products were applied at planting. All the products were applied through drip irrigation system. Looking at the gall rating data, as you can see, the resistant varieties had a significantly lower gall rating compared to the susceptible. If you look at the untreated check for the susceptible versus untreated check for the resistant, you can see there is a significant reduction in terms of the gall rating. However, if you look at the data for the plot treated with nematicide, you can see the resistant variety had really low gall rating compared to the plot of the susceptible tomato treated for nematicide. We saw the same trend for nematode counts per 100 cc of soil. As you can see, the number of the nematode in soil for resistant plot were significantly lower than the susceptible tomato. If you ended up using a susceptible varieties of tomato, as you can see here in this graph, Nimitz and Velon Prime did a better job compared to Whitehead and Magistine. However, I'd like to point out that even by using one application of Nimitz and Velon Prime, you might end up with 200 nematode per 100 cc of soil. This is a high number of the nematode. If you remember, I said that the damage threshold for root knot nematode on vegetable crops is only one nematode. That means that this amount of this high number of the nematode can be an issue, can be a threat for the following crops grown after tomato. If you're double cropping, or if you're growing 3 crops on the same plastic mulch, you need to consider more application of, for example, Velon Prime, or one application of Nimitz at planting, and another application of other product like Velon Prime or Whited at mid season. That can help to actually suppress the nematode in the soil and reduce the damage. Looking at the yield data for tomato for the resistant and susceptible, we really didn't see any significant difference. However, as you can see, the plot treated with nematicide for the susceptible had a numerically greater fruit yield compared to the resistant varieties. We move forward. I'm going to briefly talk about the chemical control of root rot nematode in cucumber and watermelon. I have had a few calls from growers who had a problem with drench application of Velon Prime on cucumber. Basically, they saw burning of their plants when they use Velon Prime as a soil drench application. We did a trial to see what is the issue. In our trial, we use 2 nematicides, Velon Prime and Whited. However, the Velon Prime at the rate of 6.5 fluounce were used either at planting or 3 days after planting through drip irrigation. In another treatment, we had soil drench application of Velon Prime at planting. We also included Whited at the rate of 64 fluounce per acre, again at planting, and untreated shade. If you look at the data for phytotoxicity, you can see that the plot that received soil drench application of Velon, they had a greater phytotoxicity compared to the other treatment. 0 means no phytotoxic damage, and 10 means the high phytotoxic or maximum phytotoxic damage. And a value of 8.2 shows that the soil drench application of Velon Prime is not recommended for cucumber. These phytotoxicity can also affect the growth of the plant. As you can see, the vigor rating for the cucumber for the treatment of Velon Prime here was significantly lower compared to the other treatment. For the gall index, as you can see, all of the treatment, whether the nematicide being used as a soil drench or drip application, they significantly reduce the gall rating compared to the untreated control. Here in this picture, you can see some phytotoxic damage caused by Velon Prime. You can see some burning at the edge of lower leaves. The plants might revive. However, it can be the whole production season can be affected by if you saw some phytotoxicity on your plant. In my last slide, I'm going to give you some data for the nematicide trial that we did for nematode control, the nematode control in watermelon. In this trial, we had 3 nematicide. However, we used the recommended rate or half a recommended rate. The recommended rate was used at planting, whereas half a recommended rate especially for Velon Prime and Whited was used either at planting as well as 4 weeks after planting. The Nimitz product was used 1 week after planting. If we look at the data for the gall index, again, using a scale of 0 to 5, Nimitz had a lower gall index and nematode count compared to the other treatments. However, if you look at the data for yield data, you can see that the yield for plot treated with Nimitz were significantly lower compared to the other treatments. In terms of the nematode control by other nematicides, you can see that the vellum prime in this treatment had a lower, at least numerically lower gall index compared to the other nematicide. The same story here for the vellum prime at the 6.5 fluence. You can see numerically lower nematode count compared to the other except nemis compared to the other nematicide as well as untreated control. I'd like to thank you in this slide. I'd like to thank you, my former and current lab member, and also county extension agent who collaborate with us. Without them, all of our trial cannot be done. I also would like to thank Trias Ag Company and funding source. As you can see, the list of the funding source are here. Without their support, we can't really do any research. In this slide, I would like to introduce you another online workshop for management of plant-parasitic nematode in vegetable crops. This online webinar will be in January 25th, on January 25th of 2021. We have different, we will cover different nematode and different vegetable crops. As you can see, the agenda, there will be a few speakers from multiple states. So if you are interested, please join us. At the time that you are hearing this talk, the link for registration will be available. Please contact me directly, or you can find more information in my Twitter account. I would like to recommend everyone who are interested to learn more about the biology and management of plant-parasitic nematode to attend this webinar. With that being said, I would like to thank everyone for your attention and have a great day. Thank you.